Hello folks, this recording is for Pre-Algebra Chapter 8, Lesson 1, and we're talking about relations and functions. And this is where we have uber-duper vocabulary, but it's also uber-duper vocabulary that will never go away for the rest of your mathematical career. So it's a good time to start learning it now, because when you get to 8th grade, Chapter 4, I'm going to expect you to already know what a domain, range, relation, and function is. Okay, so you can treat this as a preview, but you can also treat this as the very first time you need to really understand this. So please really understand this. Okay, so a relation is a set of ordered pairs in braces. And if you've ever wondered what a brace is, it's that, okay? And the ordered pairs are inside of the braces. And whenever you have ordered pairs grouped together inside of braces, those ordered pairs are the relation, and they have a relationship together. It's kind of like they're off in their own little world and they all go together. All right? So, the domain of a relationship is the x in the xy. So it's always the first number in each ordered pair. So if you were to look at the example from before, the first number in each ordered pair is the domain. So it'd be 5, 7, and 9 in this case. And this is how we write the domain. It would be bracket x colon 5, 7, and 9. And this is kind of an overkill way of doing it, but I'll expect you to write it this way when you get into Algebra 1 Chapter 4. So go ahead and start practicing now, and you'll be really good at it next year. Okay, so if the first number in the ordered pair has a fancy name, a domain, the range also is a fancy name for the second number in the ordered pair. All right, it's the y in xy. And in this case, the example is 6, 8, and 10. All right, and again, we write the domain like that. Okay, moving on. All right, now, we can have special type of relations. Some relations form what we call a function, and that means that the relation does something special. It means a relation is a function when each domain value, so each x value is paired with exactly one y value. All right? That means that for every x, there's only one y that goes with it. So if 2 is 3, so if I have like 2, 3, I can't also then have 2, 4, because 2 only goes with 3. And by saying that 2 also goes with 4 means I'm not going to have a function. Okay? So let's go ahead and look at some examples. First example I have is 5, 6, 7, 8, and 5, 6. This is a function because the 5 is only paired with the 6. And again, when they're in the braces, we only care about what's in the braces. It's kind of like these things are own little world, and we're only looking at that world at that moment. We only have these things in those braces, so that's only what we're going to look at. As far as we know, 5 goes with 6, 7 goes with 8, and 5 goes with 6. Since there's nothing else going on in this little world of this little relationship, in this relation, we can only base whether we're going to call it a function or not a function based on what's in it. So since 5 goes with 6, every time, as far as we know for this little world, and every time 7 goes with 8, it is a function. Okay? So same y for 1x equals a function. All right, so this particular example is a function because again, there's 1x for each y. Or no, there's 1 y for each x. There's 1 y for each x. So an x can only have 1 y, but different x's can have the same y. Okay, which is in my next example. We have 5 with 6, 7 with 8, and 9 with 6. Because I don't have two different 5s with a different y, it's okay. It's okay that both 5 and 9 go to 6. It's when 5 goes to two different y's that it's not okay, or 7 goes to two different y's, it's not okay, or 9 goes to two different y's. That's when it's not okay. When the first number has two different y's that it could be, that's when we've got a problem. So this one is all x's are different, so automatically it is a function. And that's something you can look out for already. If you all have different x's inside your relation, then it has to be a function, because that means there's no possible way that one x could have two different y's. Okay, so again, if all of the x's are different, then it's automatically a function inside that relation. All right, so let's look at this one. I have 2 5s, and both 5s, I have 3 5s, so all 3 5s have a different y. So different y values for the same x value, in this case 5, means it's not a function. Okay? All right, let's move on. So, using a mapping diagram. So we're going to use mapping diagrams to determine if a relation is a function. Here's the example. Is the relation a function? 0, 1, 1, 2, 1, 3, 2, 4. Some of you guys can probably just look at it from what we talked about on the last slide. For the rest of you, here is a technique to help you figure it out if you just can't look at it. Okay, so to make a mapping diagram, you're going to make 2 lists, one of the domain and one of the range. And you're going to put each list in order, so like 0, 1, 2, 1, 2, 3, 4, and only once. So even though I have 2 1s in my domain, I'm not going to repeat them. I'm only going to use it once. Okay? Then the range on the left, again, in order and not repeating any numbers, and then we're going to draw arrows to match the domain range. So 0 goes with 1. 0 goes with 1 right here, right? 0 and 1 go together. So I'm going to draw an arrow. 1 goes with 2, but 1 also goes with 3, and 2 goes with 4. All right, so see how I drew those arrows right there? Now, because 1 in the domain goes to 2 different ranges, in this case 2 and 3, it means it's not a function. Okay, so whenever you can draw 2 arrows off the same domain in a mapping diagram, it means it's not a function. Not a function. Okay? So, just remember, no repeats, even though there are repeats in my relation. And just remember that they're all in order when you are making a mapping diagram. Okay, let's move on. So, here are some functions can model many everyday situations when one quantity is dependent on another. One quantity is a function of the other. So here's some examples that are functions. The weight of a turkey will determine how long it needs to cook. So if the weight of the turkey is the domain and how long it needs to cook is the domain, I'm not going to have a 20-pound turkey or even 50-pound turkey that needs to cook at the same temperature as a 20-pound turkey, or even a 120-pound turkey that needs to cook at 4 hours and 120-pound turkey that needs to cook at 2 hours. The weight of the turkey will determine how long it takes. So therefore, the same weighted turkey won't take 2 different times to cook. Hopefully anyway, unless you've got some really funky directions. And in that case, I hope you don't get food poisoning because of an ill-cooked turkey. Anyway, another example would be the weight of a package will determine the cost of it to ship. Sometimes this actually doesn't make any sense just because you might have a much larger package, and even though it doesn't weigh anything, they're still going to charge you the same amount as shipping. So this is not the best example, but again, the weight of a package will determine the cost to ship. So if we're not worried about the size of the package and we say, all right, I have 2 20-pound packages, as long as I ship them at the same place, it should cost the same amount. I'm not going to have one 20-pound package that's going to cost me $20 and one 20-pound package that's going to cost me $40. Now, again, as long as I'm obviously shipping them to the same place. So again, if the domain is the weight and the range is the cost, again, I'm not going to have 2 different costs for the same weighted package as long as they're obviously going to the same place and they're probably the same size, even if they, same size. Same place, same size. Okay. All right, so here are some relations that are not functions. How tall you are determines your weight. You could have a really tall person that weighs not a lot and a really short person who weighs quite a bit. So again, your height does not determine your weight, and your weight does not determine your height. We could have 2 people that weigh the exact same amount, like 140 pounds, but then have them be different heights. Okay? So again, see how this works out. And then the last one is the number of nail clippers you have determines the number of toes you have. If you have 10 toes, can you still have 2 nail clippers? Yes, but you could have 5 toes and 2 nail clippers. All right, see how they're not quite, they're definitely not a function. It's not like I have a nail clipper for every toe. Okay, all right. So next up, we can use the vertical line test. Actually, the vertical line test is a visual way to determine if a relationship is a function. And to do that, we're going to graph the ordered pairs, which I'm going to do in just a second. Graph the ordered pairs, and then we're going to pass a pencil that is positioned vertically up and down. Now, I'm going to use a straight line tool in Docere, but you can do the same thing with a pencil or the edge of a paper. And you're going to move the pencil or paper from left to right across the graph. If the pencil covers up more than 1 dot at a time, then it is not a function. If the pencil doesn't cover up more than 1 dot at a time, then it is a function. So here's my pencil. There. Am I covering up 2 dots at a time? No. How about there? There and there. No. So I have not covered up 2 dots in one straight line. So therefore, it is a function. Right? So that is a function. Now, what happens if I go ahead and get another function, or excuse me, another relation, which looks shockingly like that, and I'm sure some of you guys can look at it and go, Miss DH, I know it's not a function, but let's go ahead and prove it using the vertical line test. So we're going to graph the points, and we're going to use a vertical line to do it. And guess what? Right there, that vertical line covers up 2 or more dots with the same line. Therefore, not a function. Okay, guys, I am done. A lot of terminology in this one, so I really hope you know it. Okay, bye.